I stole my brother's SD card because I'm all full up. Might as well show you the view while I'm at it. Good view. Yeah, the backyard isn't a beauty, is it? Alright. This is... My brother lived on this thing for like 10 hours a day. Yeah, we're weird around here. It's actually a flight simulator, but I don't want to touch it. He'll get very angry if you see this video. Okay. A lot of tools. People are wondering, we were going to remodel the house to make it look like a house, right? Well, it turns out issues with my grandfather didn't let that come to fruition. Here's my driver. I'm actually going to get a new driver. Well, I'll probably end up just getting a tideless driver because I don't want to spend the money on a bunch of irons. I don't like irons. And this is what happens when you get water in your air tools. You have to get one of these. And I actually got my dad to get it. Auger, blower, lots of Coke cans, and lots more stuff. Now, what I want to show you with this beauty here. This is my Chinese, I don't even remember the brand. It's a Chinese dyno. It's made off, it's a rip-off of the Japanese one that I was originally going to buy for like $3,000. But I'm not going to pay that much. And it came with a computer program and a software program, but it didn't work. I couldn't get it to work. Maybe I'm retarded, but I tried everything. I went through it. My brother took a look. He couldn't really figure it out, even though he hacked all the Adobe programs when he was 16. No, wait, when he was like 14. I actually got, he got After Effects, like Premiere, all that stuff. Premiere's Apple. I don't even know anything about software. But anyway, so you basically take your engine and spin it, and you get a torque reading. Well, how cool is that? I got it for like $1,000. And what I was going to measure is my turbo shaft. I was going to make a turbo shaft out of this big Cummins turbocharger, Chinese turbocharger I got for $300. Actually, I think I paid $160 with shipping. Yeah, I paid $160 for the turbo, but shipping was the other half. And then I got this flow meter because what I was going to do is I was going to build a hydrogen-powered jet engine, then end up making a turbo shaft. But I realized I live in a residential house, so it wouldn't really work because I don't have hydrogen. And if I want to buy hydrogen, I went to Praxair, and they said that, well, that wouldn't work out too well. But it's nothing safety related. It's just the size and the amount of tanks I need. And there's my gearbox I got from this Russian guy. It's a gearbox of some old British jet engine, I think. It's for an APU, not a jet engine. It's a small little turbo shaft. It's a real gearbox. It's really cool. But yeah, I'm gonna get all this working. I just need the hydrogen, and then this is my flow meter. This is a Vortex flow meter that I got for $500, and I even got the system so that I could read it. I could read. Oh, this is my my temperature probe. Or no, the reads the temperature probe, and it's one of the yellow ones. It's not the. There's two different kinds of fittings, but and then I got a screen for my flow meter, so I get the flow rate in NM3. And I was actually going to measure the mass airflow into the engine. I was going to measure and then the temperature, because what I want to prove is a theorem that was developed by this aircraft pioneer. And the theorem is that if you run the engine on liquid hydrogen, you can reduce the specific fuel consumption by 2.93, and you mathematically calculate it. I want to prove it because I'm just weird. But yeah, so that's my dyno. That's my flow meter. I'm gonna gotta get it all hooked up once I get my hydrogen figured out. But I end up realizing that it wasn't going to work because I can't have a liquid hydrogen tank in my living room. That's not going to work. Where am I going to put my liquid hydrogen tank? Well, I could put it in the backyard. But if I put it in the backyard, it risks being an issue because my dad burns stuff over there. And my dad's really funny. He gets upset if I upload personal stuff, but like they can look at you the satellite. Have you thought of that? And they can also see your smoke. But anyway, so this is where I was planning on building. I was actually going to build an underground house right here. So I was going to build an underground house because why underground? Well, because the HOA we live in doesn't like all my stuff, and they've complained about it many times. This was my home for like, I want to say 4 years. I actually lived in this house all alone because I was fed up with my parents screaming all the time. But I don't know what my dad's collecting. But yeah, my brother actually flew over here in the helicopter, and his flight instructor said, "That's an interesting backyard you got there." But and my dad's so weird; he actually get upset if I upload this, but he'll never see it. He doesn't quite understand the helicopters can see it. If they want to fine him for fire hazards, they're welcome to do that. But yeah, so about the liquid hydrogen tank. So I was going to build a stainless steel. I was going to get the stainless steel and then spray like 15 inches of foam, closed cell foam, because I didn't have to worry too much about the boil off. I ended up realizing I could probably get the LH2 tanker to drop by the house. I would make it on wheels. Well, actually, I could probably move it back there. He would fill it up there because I couldn't drive it because it wouldn't be DOT certified, DOT certified. I can't have a homemade hydrogen tank in my truck because, we have a pretty big truck and you can put lots of stuff in there. But anyway, like I said, it just wouldn't have worked. So I ended up thinking, well, I could build the hydrogen tank and drive it in the truck, but that wouldn't work because it's not DOT certified. Then I thought, well, I could buy a bunch of steel canisters, right? The ones you rent for your welders, acetylene welders, right? But that wouldn't work either because I'd have to have like 100 of them to run the engine for 5 hours, right? And I ended up doing the math. I could, on one can, the ones they sell you, it's like I could run the engine for 10 minutes or something. Because I was going to get a bigger turbo on the engine. It's a HX55 turbo. I was going to get an HX82, which is all the turbojet guys on YouTube. Oh, one thing I wanted to show. The oil fitting was fun because I had to call Cummins to get the right oil fitting. It was a lot of fun. And I have to get all the hydraulic stuff figured out. But basically what I want to test is how much thrust I get if I burn propane, how much thrust I get if I burn hydrogen. And I like CFD programs, but A, they're expensive. They're not as fun. And oftentimes you don't really know what's going to happen because fuels perform weirdly. For example, methane burned at very high altitude, according to NASA, actually has lower combustion efficiency. Like, who would have guessed that? They went up there and tested it, right? And the other thing is, I want to build a hydrogen liquefier, but I can't really do that. The cool thing is, my dad bought 20 acres in Nevada, flat, right by Interstate 80. And so I can build all this junk, well, not junk, over there. And if I have an explosion, which, there's a good chance that will happen with a jet engine, I don't have to kill myself because I can build, like a concrete room. Well, I have like, I'd end up I'd like to get like a RB211 or something, right? You can get these used and run it on hydrogen because, I'm a hydrogen buff. I think aircraft eventually are all going to be hydrogen powered. But I want to do some testing, like for example, there's issues the Japanese tried and are trying right now. And what they find is they have issues of so-called flashback, where you essentially have combustion where you don't want it. The combustion migrates rearward into the sort of forward portion of the combustor just after the diffuser. But yeah, you don't really know what's going to happen so much with the hydrogen when you burn it. in a jet engine. No one's even studying this. You have to understand that it's all on paper. Airbus tried the cryoplane, okay? Daniel Brewer and Willis Hawkins at Lockheed Martin tried hydrogen on paper. They were the first ones. Actually, I think there was this Jewish guy who first conceived of it after. It was old. I mean, look, hydrogen, in fact, I think it goes all the way back to, I was reading this on the plane when I was going to France. I was reading a book on the history of liquid hydrogen. And I remember reading that one of the rocket designers, the early Russian rocket designers, went through a dictionary to find the lightest fuel. No. I'm wrong. P. Myers in the U.S. wrote a paper called "Is There a Fuel That's Lighter Than Gasoline?" Something like that. And of course, they found hydrogen. The problem is, he hadn't thought to liquefy it and ended up realizing, well, the tanks end up being heavier than the... And by the way, Alan Epstein at Pratt & Whitney's wrong. He's wrong. Because Alan Epstein, if you watch this video, he says if you made a hydrogen airplane, the tanks would end up weighing more than the fuel. Now, if he had bothered to even read Brewer's book, he would have known that that's bullshit. And the other thing is, you're not going to use fuel cells. I'll tell you why. When you burn things, you get always a lot more power density than if you do things electrochemically. That's just a rule of thumb. You're never going to make a fuel cell as energetically dense, as power dense, as a turbine. It's just not mathematically, physically possible. Remember, how does a jet engine operate? A jet engine operates on what's called a Brayton cycle, right? A Brayton cycle is a constant compression combustion cycle. So it's constant pressure compression, constant pressure compression. All right? What that means, what that basically means is that it's very, very power dense because you're not oscillating. You're not turning the combustion off. I mean, fundamentally, that's what you're doing. With a diesel engine, you're turning combustion on, turning it off, turning it on, turning it off. With a gas turbine, it's constant. So by definition, it's like 100 times more power dense. Like if you take a helicopter engine, which are these little, amazing little things. They're so small. If you go up to them in real life, I'm going to Heli Expo 2019, and I'm going to check out some of these engines again. They're like... a foot and a half in diameter, maybe 3 feet long, and they make 1,000 horsepower. It's like if you wanted to get that out of a diesel engine, it would weigh 3,000 pounds, right? So, and they weigh 200 pounds. So it's about 100 times, over 10 times more power dense. 100 is too much. It's just about 10 times more energy dense, or power dense. I mean, energy density and power density are actually sort of the same thing, but one's a measurement of fuel, one's a measurement of how effectively you can take that fuel and convert it into power. Right? It's an interesting thing because on small aircraft with short range, it's the last thing you want to do is use a heavy power plant like a diesel engine. There's actually a Russian engine that was developed. I don't know if anybody's seen the Auto Solera 500L. It's this aircraft from Southern California, and it's an interesting beast. The designer is a former avionics designer on the B2, the B1 Rockwell B1 Lancer. And anyway, he had designed this aircraft, and I had actually thought of a similar concept where you basically do transatlantic flights with very small, hydrogen-powered, really bulbous aircraft. And why bulbous? And because if it's bulbous, then in terms of the fuselage shape, then I can fit more hydrogen because you know how to surface volume ratio. If I increase the diameter twice, I quadruple or sextuple my volume. I don't know exact math, you have to do it on paper, but basically if I increase the diameter, a lot more volume I get than if I increase the length. So that's why hydrogen doesn't work very well for supersonic, but it works great for like a wide body. Where the fuselage is nearly 30 feet wide on the the MD-12 or the McDonnell Douglas concept that was
going to be bigger even than the A380. I think the height of the fuselage was 26 feet, right? So with that kind of fuselage diameter, you can fit all of the hydrogen needed to power the aircraft a long distance. And so yeah, that's that. But yeah, what are some issues that Daniel Brewer found on hydrogen aircraft? One of the issues he found was, well, I guess piping, plumbing, and all that. It's a cryogen, so getting it from the wings, getting the engine to the wings from the main tank is going to require some more elaborate engineering. It's not going to be very heavy or anything. I mean, you just have very lightweight aluminum pipe. Remember, it's at basically no pressure. It's at atmospheric pressure. And the other thing is, see, Brewer, the Soviets obviously tried hydrogen in aircraft, but they were using helium to keep the pressure up in the tank, and you don't want to do that. You don't want to take the technology. You might say, well, if you're going to build a hydrogen aircraft, you're going to take the greatest hydrogen technology, which is the Saturn rocket, and convert it to aircraft. No, you don't want to do that. You don't want to use helium to pressurize it.